Fortissimo Project and a little bit beyond that. But I'll start off one level higher than Fortissimo, because Fortissimo is actually part of a larger initiative, and I'll explain that initiative. And then I'll give you an introduction to the project and its objectives. And then a quick introduction to an overview of all the Fortissimo experiments. The Fortissimo experiments, as you'll find out, are the key part of this project. The whole project is based around execution of a set of business experiments. And I'll give you some examples of the sort of business impact success stories. So I've already mentioned I4MS. I4MS is a program or an initiative within the Factories of the Future program of Framework Program 7, EC-funded Framework Program 7, and now also moving into Horizon 2020. I4MS stands for ICT Innovation for Manufacturing SMEs. So you see this focus on manufacturing, supporting SMEs in the program. And this is a much abused diagram. This chasm has all sorts of different names and all sorts of different strategies for jumping across that chasm and moving into the bulk markets and the large uptake of technologies. And I4MS has also used or misused this diagram. But the idea is that in a range of technologies, and I'll show you some of those technologies in a second, I4MS is there to actually promote the use and encourage the uptake and move from the early adopters to the larger bulk of manufacturing SMEs that could make use of new technologies. That's what I4MS is about. An HPC cloud, or HPC simulation in a cloud-based environment, is a key issue. So HPC cloud-based simulation services in I4MS. There are 3 projects looking at that. There are Fortissimo, which is the largest of the projects and the largest number of experiments within I4MS, Cloud SME and Cloudflow, but a range of other relevant advanced technologies that can be used in manufacturing. So new advances in laser technologies with robotics, or intelligent-based sensors. So you can find more information about I4MS on their webpage and links to the various projects. I've already mentioned this. Fortissimo is part of the Factories of the Future initiative, I4MS, and it's, as you have gathered, it's about building a cloud of resources. And resources doesn't just mean hardware, and we'll come back to that. Resources means a whole range of services and know-how and technologies and competences. So those are the resources that we bring together. And it's targeting SME business challenges. So it's not a usual RTD project. It's not about performing research to develop new technologies. It's about taking existing technologies and performing business-related experiments. We're interested in solving actual problems from SMEs. And in that sense, not really academics. We're focusing on industrial use, manufacturing use, solving business problems. So that's different than many other projects. It focuses on SMEs, and in that sense, it complements other activities within the whole Framework Program 7, which is now closing, and Horizon 2020. So there are SME programs in general, and I4MS and Fortissimo focuses in particular aspects for supporting SMEs. And what we want to do, and we'll mention this marketplace later, you'll see the next presentation we're going to do is about the marketplace, but what we want to do with the marketplace is bring together all the key service players, the service providers, technology providers, to provide a marketplace for services for SMEs. And our goal is in a sense, obvious. There's a lot of, it's actually already established that high-performance computing is an enabling technology that can make a big difference. Large industries are already using HPC for some time, and for them it's a key element of their design and development process. And what we want to do is to make sure that or to try and achieve that sort of breakthrough can be passed on to a larger set of manufacturing industries and to SMEs in particular. So what the large companies have already learned for some time and what has been established as a key factor in business development in countries, so innovation is empowered by HPC, we want to move that over to a larger set of companies that can make use of it. So we're targeting improved competitiveness, better and new products. And when you see the business impacts, those are the questions we're asking. What impact did it make? Not what did you do and what was the scaling and what's the performance, but what difference did it make for that SME's problem? Fortissimo as a project is very large. In total, it will have around 22 million euros costs, and the funding for that will be 16 million. So we have 16 million EC contribution for the project. We started off with 45 partners, and then as you see here, we had 2 open calls for proposals for additional waves of experiments, and I'll explain those later. So we started with 20 experiments, and then we added another 22 and then another 11. We've ended up now with 123 partners. So it's a very large project, executing over what will be 3.5 years. And it's all based around experiments where we bring together the key players to perform the business investigation for that experiment, for that end user's problem. So each experiment looks a little like this. They don't have to have all the players involved, but typically, well, it's always end user centric. What are the end user problems I want to solve? And who do I need to realize that? So typically I'm going to need a software vendor. So it could either be an ISV or a research software provider. I will need HPC service infrastructure, so I need the HPC service provider. And then I may need additional experts if they're not included within the software provider. So HPC experts or application experts. So each experiment is made up of this sort of collection of key players. And the whole project is made up of 3, I'm going to call them clouds, 3 clouds of experiments that perform these business investigations and are supported by the core activities in the project to bring all these together, look at advanced planning for sustainability and create a marketplace where such experiments, such business activities could be performed in the future. And that set of activities we refer to as the marketplace. I'll say a little bit more about that in a second, but essentially the marketplace brings together all those players for all those business experiments, all those business activities, providing the necessary resources, hardware, software, competences, know-how, consultancy, to allow those sort of activities to be performed. So the marketplace brings all of those little experiments together, providing all the key players that you need to do those sort of investigations, and then to move into the future, into operational mode, to allow those sort of remote HPC simulation activities to become services provided to SMEs in the future. The next slide is rather full. I'm not going to go through the details, but it has a couple of ideas. The vision of Fortissimo is to provide simulation as a service. In the cloud context, everything is as a service these days. Our vision is that simulation should become a service, which is not just software. It's access to the Fortissimo cloud, and that cloud combines and integrates all the resources I already mentioned. So it's hardware infrastructure, know-how, simulation services themselves, application software, etc. That's the cloud of resources. And the marketplace is the one-step shop that end users can use to access those services, that ISVs can use to bring their services in to offer them to end users. So the 2 ideas, the key vision is simulation as a service, and it's realized through the Fortissimo cloud and the marketplace that provides access, one-stop shop access to that cloud. You'll hear more about the marketplace in a second. I'm going to show you a couple of screenshots, but essentially what you'll see, the set of Fortissimo services. It's going to be based on the HPC infrastructure, so computing center hardware and service infrastructures in the HPC infrastructure, and then a set of services on top. The very top one is simulation as a service, where an end user can come and find a service that performs simulation for his business needs or his particular modeling and solution needs. And that can be realized as a platform as a service for expert users. Say, I know what software I want to use, I know how to do it, but I don't have the resources that I need that are large enough, fast enough to solve my problems quickly. I have an urgent need. Then they can use platform as a service. But below that, a whole set of possibilities to provide support services. Business Containers allows ISVs to offer their solution, their simulation as a service solution within a shop option within the Fortissimo marketplace. We have options for providing support, providing consultancy. That means people in the loop, experts in the loop within the marketplace, or performing code validation, or matchmaking. You have a problem, you want to know who can solve my problem, how can I find the right people? Fortissimo will help you do that. Just to mention the HPC cloud the hardware infrastructure, the centers, these are the centers that we have across Europe and involved in the Fortissimo project and involved in the Fortissimo marketplace. We have University of Edinburgh, EPCC, Bull, Surf-Sara here in Amsterdam, Arctor in Slovenia, HLRS in Stuttgart, Cinica in Italy, headquarters in Bologna, I think, Cesca in Spain, and Compute, which is centered in Stockholm, multiple sites. One piece of news is that in summer 2015, the first marketplace will be made available open to external use. So people should look out for the marketplace coming online and being available. You'll hear more about this later. What it will do, how can we help you? It will offer possibilities to access experts and find solutions. That will be the first step. More about that in a second. I'll finish off the presentation, not very quickly, but I have a number of slides still, but talking about some of the experiments and giving an overview of what's been done. This was the original, I call it, cloud of experiments. It has quite a range of applications, not all of them strictly manufacturing. So we have some environmental problems, some pure engineering problems, some of the themes that you might call the typical or usual suspects, so CFD and structural mechanics, but being applied to new types of users, and particularly with a focus on SMEs. So that's the range of applications. This was extended with our first call for proposals and our open call for new experiments. We selected 22 new experiments in that call, and a range again of activities. Some focus on manufacturing, but some new areas like marine sector, marine industry. Some pharmaceutical, some more general, some more advanced applications like crowd sensing, in smart cities. Oil and gas applications as well. And in our final call, we added some further experiments. Again, strong focus on manufacturing, but some other areas like biomechanics or microscopy. And then structural mechanics, but not for automotive in the classical sense, but motorcycle helmets as a new application, or a new technologies and shape optimization. And again, we see an interesting focus on environmental and marine technologies, which came out of the competitive open calls. You've already seen an advert for this. It's what I would call recommended reading. There are some very interesting success stories in the brochure, focusing on a little bit on what they did, but what the impact was for each of the SMEs. And I'll go through a couple of those now, focusing not, as I said, on how and what, not the mesh sizes and the scaling and the pressure fields, but actually what it meant for them. So for Pipistrelle, they were able to do some, what you might call cloud bursting. They had some extreme requirements for times that they needed to do very high resolution studies. And because they were able to use systems at Arctua, they were able to do that very cheaply. So they were able to reduce their design phase and the number of design cycles by using high resolution simulations, which cost them a factor of 10 less by using external resources than if they were trying to set up that sort of system in-house. The next application is from Ergoline, and this is in steel casting. I'm not going to explain what slag detection is. I'm not sure I could. My understanding is that slag is a sort of waste product or a waste created during the casting process. And through improved design, you can minimize the waste that happens in the process. And what they saw is by using HPC simulation, a typical medium-sized factory could avoid having to remelt this slag. So they could save 600 tons of steel waste that had to be remelted and then cast again, which is something like a 670,000 euro saving for a medium-sized factory. A totally different type of application is in high voltage cables. Prysmian is an SME that does design. And they were able, through using HPC, to move from 2D to 3D simulations. So not only does that allow them to do better cable design, but it maintains their leading position in that industry. And again, because it was a peak demand that they had on-demand computing, they had a major saving than if they were going to try to invest in in-house solutions. Another application field, again, IES is an SME in Glasgow, but it has worldwide offices. They are involved in building design. Actually, one of their key products is thermal properties of buildings and managing and optimizing thermal properties. So for shade and for energy reuse. And what they were able to do was to use the Fortissimo approach to offer their customers an on-demand option, actually through the usual desktop. So the customer didn't really see that he was going outside and using HPC, but what he did see was that instead of having simulations that took days or weeks, this was reduced to hours or days. And again, because it was on-demand computing, this is 50% cheaper than if they were trying to do that in-house with their own servers. Another application is aircraft wiring. KEW is an SME that specializes in optimization in engineering applications. And they were using HPC for the design optimization of the wiring in aircraft. And what they found was their optimized solution led to a 2.5 reduction in the cost and weight. That's not of the wires, but of the overall aircraft. So they made a 2.5 reduction in the aircraft weight. And there's not just an advantage for them in terms of competitiveness and profit on their design deals, but there's an environmental impact, because what you see, what they told us is that there's something like a 20 times impact on the overall weight of an aircraft. So every kilo you can save in the wiring leads to a 20 kilo overall saving in aircraft weight, which means this has a large impact for aircraft that are flying many flights and over their lifetime. So there's an environmental impact, saving in fuel. Moving to chemistry, Lonza, it's a Swiss company that manufactures distillation columns for hazardous chemicals, including hazardous chemicals. And they were able to greatly reduce their design cycles for those, for determining properties of the chemicals from 6 months in in-house systems to less than 20 hours on a Fortissimo HPC system. So they were able to realize €85,000 saving in the design development of a distillation column. And finally, with pictures of interaction here, this is an SME that is involved in casting of copper alloys. And there's a typo on my slides. The olds should be moles. I apologize for that. They previously performed empirical studies to design the molds for the copper alloy casting. And what they're now able to do was to use HPC simulation, so working in an IT environment rather than experimentally, to reduce the time it takes them to test and modify designs. So, and the simulation that could be offered through HPC, we're able to do that in a time of 3 hours. So those are some of the examples that you will find in the case studies brochure. There is further information about Fortissimo in a number of sources, primarily the website, but as I said, the marketplace will be coming up online in summer. You can also find out more information about I4MS via their webpage or using LinkedIn. But there's an outlook ahead. I mentioned that we executed and completed open calls for experiments. Within the new, currently being negotiated project Fortissimo 2, there will be further open calls for extended technology experiments. So the focus of Fortissimo 2 will be on next generation ICT advances. Again, looking at the manufacturing domain, this will happen in the framework of I4MS 2. And the specific focus will be on coupled HPC simulations, but also on big data analytics linked in some way to these HPC simulations. Expect the first announcements in the first quarter of 2016, and expect the first submission deadline to be at the end of the second quarter 2016. And with that, I'd like to thank you for your attention and see if there's any questions. Thank you very much.